Good afternoon. We'll begin the session shortly. We'll wait for a few minutes for the students to join. Welcome to the live session 9 for the NPTEL course Basic Environmental Engineering and Pollution Abatement. This is Mahalakshmi S, Research Scholar from NIT-Trichy. This is the general information about this course live session. So this live session for the course Basic Environmental Engineering, Pollution and Abatement will happen every Saturday from 3 p.m. to 5 p.m. I will be handling this session every Saturday. You can join the session using the Gmeet link MTI VDCP NCG. This is the same link to be used every Saturday. And all the recorded videos will be uploaded on the YouTube channel Mahalakshmi S. You can find this video through Mahalakshmi Shekhar NATT. I hope the students will join in few minutes. So I will start this session since it is time. So first we will discuss the assignment solution for the week 8, and then we will see the brief overview of week 9 lectures, and then we will solve some sample assignment solution for the week 9 content, also some tutorial problems for the week 9. Okay. So in the week 8 assignment solution, the first question is, which of the following parameters affect the microbial fuel cell operation? So it is the question about MFC. So we basically know what MFC is used for. We can produce the current with the help of the microorganisms. Here electrical current uh, is produced with the help of the microbial action, right? So in this thing, which of the parameters are going to affect this MFC operation is a question. Whether it is the electrode material, pH buffer and electrolyte, proton exchange system, or all of the above. So we know it, right? All of the above is the right answer. Because in an MFC, so we have two electrodes, cathode and anode, and we have a proton exchange membrane system. So this is the membrane which specifically allow only the H plus ions, right? And the electron movement happens from one electrode to the other electrode. This is how the MFC works. And this MFC is filled with the electrolyte solution, and the pH is also constantly maintained. Okay. So this is the basic components of the uh, MFC. So what are the parameters going to affect this operation means all the electrode material, both the cathode and anode, and the pH buffer and electrolyte. So all the solutions involved here. And the proton exchange system is nothing but the membrane which is used to separate the H plus ions. Okay. So all these three are responsible for the MFC operation. Okay. The second question is, which of the following is not favorable type of MFC? So we can have a single chamber MFC, double chamber MFC, upflow and downflow. But the thing which is not favorable type of MFC is the downflow MFC. Okay, the operation is very difficult here. So downflow MFC is generally not a recommended one. Okay. Next question is, zero charge potential of the adsorbent helps to understand which of the following effect on the adsorbent process. Find the most suitable option. One is the pH effect, second is the temperature effect, third is the pressure effect, fourth is none of the above. So the question is about the adsorbent, which is asking the zero charge potential of the adsorbent is helping us to understand about which of the following effect we are asking. So here the charge potential is very much important to understand the effect of the pH. So the right answer is the pH effect. The next question is, identify the process given in the figure below. Okay. Is it a UV hydrogen peroxide, UV persulfate, UV chlorine, or a photophenton based UV ozone reaction, or photophenton based heterogeneous reaction, or photocatalysis? What is this type of reaction? So if you see the figure here, the figure has the name called photocatalyst, right? And there is an action of excitation because of which the electrons are released, and this electron is very much important for the production of the OH radical. So here the OH radicals are produced, and this is very much helpful for the tertiary treatment process. That is where we are going to use all these methods. So these are all the different types of the process called AOP, Advanced Oxidation Process. So in the Advanced Oxidation Process, this mechanism is involved in the method called photocatalysis. So all of these methods are ultimately going to produce the OH radicals which are used in the advanced oxidation process in the tertiary treatment. Okay. Next question is, advanced oxidation process AOP technique for the water treatment is, identify the most suitable option. Penton oxidation, photocatalytic oxidation, ozonation, all of the above. Just now we have discussed. So here in the AOP, OH radicals are produced by which we are going to treat the wastewater, right? So all type of oxidation which involves the penton ferrous ions and then photocatalytic oxidation, then the ozonation O3, all of these are involved in this AOP, advanced oxidation process. So the right answer is all of the above. Which of the following is the oxidation potential of atomic oxygen? So if you see the atomic oxygen O, they are asking you the oxidation potential of this one. Okay, the right answer is 2.42 O. Next question is about the adsorptive filtration. So which of the following is the first step of adsorptive filtration? We know that we have the adsorbent column. Okay, through which our wastewater is going to pass through and we are filtering the contaminants. So the first step is the transport of the bulk to the surface of the adsorbent. So we have lot of particles like this. So from the bulk particles, okay, from the particles in bulk. So only few of the particles are going to the surface of the adsorbent. So first step is transport of adsorbate from bulk to the surface of adsorbent. And then the second step is diffusion of the adsorbate into the interior part of the adsorbent. Then it is going to diffuse. Next only absorption of the adsorbate by different possible sources. Okay. So the first step is transport of the adsorbate from bulk to the surface of the adsorbent. So here one thing constantly you have to keep in mind is the difference between the adsorbent and the adsorbate. So if you see the adsorbent here, it is the bed. Okay, so this is the adsorbent. So it is used to capture the contaminants. Okay. Adsorbate or the particles which is going to stick onto this adsorbent. Okay, so these are the solid particles which are going to adhere to the adsorbent based upon the physical or chemical interaction. So these contaminants are called as the adsorbate. So these particles which adhere to the surface are called as the adsorbate, and the matrix which is used for the capturing of the pollutant, that is adsorbate, are called as the adsorbent. Okay. So here the first step in the adsorptive filtration is transport of adsorbate from bulk to the surface of the adsorbent. So from the bulk quantity to the surface of the adsorbent it is going to pass. Then through physical or chemical interaction, some will be adhered to it and some will be going to diffuse into the interior part of the adsorbent. Next question is, in case of microbial fuel cell, high power output can be obtained using. So in the MFC, we use the microorganisms, right? So these microorganisms are very helpful in the electron generation, okay, under the electric current is that. So the efficiency can be depending upon the type of the microbial culture we are using here. So the different option given here are the pure bacterial culture, that is having one type of bacteria completely. Mixed bacterial culture is having many different types of bacteria, both A and B. Both A and B means pure and mixed bacterial culture is the right answer they are asking. And fourth option is none of the above. So here in the case of MFC, high power output. So high power generation can be obtained by using which type of culture they are asking. The right answer is the mixed bacterial culture. So if we use different type of bacteria in the MFC, the power output will be very much higher than the pure bacterial culture. Okay. Next question is, identify the following membrane module. So if you look at this membrane module closely, it has the perforated PVC baffle, then the paper substrate over it, and the cellulose acetate membrane is also there, and it has the root phenolic support plate. It has both the plate and the membrane in it. So this is not a just a large tube, or it is not a spiral wound. Okay, it is the plate and film. Okay, right answer is plate and film. The next question is 100 ml solution containing 50 mg per liter fluoride is treated with adsorbent dose of 6 gram per liter. The percentage removal of the fluoride was 90%. Calculate the specific uptake. So we have discussed the same kind of problem in our previous section, right? So the question is 100 ml of the solution is containing the contaminant, here the fluoride, okay, which is of concentration 50 mg per liter, and it is treated with the adsorbent concentration 6 gram per liter, and percentage of fluoride removed is 90 percentage, and they are asking the specific uptake of this particular fluoride for each gram of the adsorbent used. So the right answer is 7.5 mg per gram. We will look into the solution now. So consider this as the adsorbent. Okay. So our adsorbate is the fluoride. Right. So fluoride is the adsorbate fluoride. The concentration is 50 mg per liter. This is the initial concentration of fluoride. Okay. So when this 50 mg per liter of fluoride is passing through the adsorbent, 90% is removed. So removal percentage is 90. Okay. 100% is 50 mg per liter. So what is the 90? So this is the 100% of contaminant. What is the 90% of 50 mg per liter? 45, right? So 45 mg per liter. And only 10% is passed. 90% is absorbed in this matrix, right? So 10% of 50 mg per liter is 5 mg per liter. So these are the concentration present initially, went out in the adsorption matrix, and this went out after the adsorption matrix, present in the adsorbent matrix. Okay. Now they are asking you to calculate a specific uptake. So here the adsorbent used is of concentration given 6 gram per liter. Okay. So 6 gram per liter is the concentration. This is for every 1 liter of solution, 6 gram is used. Here the amount of solution used is given as 100 ml. So for 100 ml, it is 0.6 gram. Only 0.6 gram is used. Okay. Now the solution is also 100 ml, right? So here the concentration is 50 mg per liter. So if it is 100 ml means amount in terms of mass, okay? For every 100 ml, how much amount is present in the adsorbate? 4.5. Per liter it is 45 mg. So for 100 ml, 4.5 mg is going to be residing in the adsorbent matrix, okay? And here the amount left out in the case of 100 ml solution is, for every liter 5 mg will be there. In 100 ml, absolutely 0.5 mg only will be there, right? So now we have found the mass of the fluoride present in the adsorbent and mass of the fluoride leaving the adsorbent. So the specific uptake is calculated by dividing the amount of fluoride absorbed divided by amount of adsorbent used. So that is what given here. Okay. This is the overview of solving the problem. Now we will solve this step by step. So initial concentration of fluoride is 50 mg per liter, and the final concentration is 100 minus 90 is 10%. That is what taken in fraction here. So 50 into 1 minus 0.9 is 5 mg per liter. That is what leaving the matrix. Now the adsorbent used is 6 gram per liter. So for 100 ml it is 0.6 gram. If removed by the adsorbent is nothing but 50 minus 5. Okay, 50 minus 5 is 45 mg per liter. For 100 ml, it is 4.5 mg. Okay, that is what we have calculated here. Now the specific uptake is equal to uptake of the fluoride by the adsorbent matrix is 4.5 mg and the amount of adsorbent used is the zero point 0.6 gram. So divided 4.5 divided by zero point 0.6 is 7.5 mg per gram. So the right answer is 7.5 mg per gram. Okay, I hope this is clear. Okay. So now we will move on to this big lecture. So this big lectures are about the sludge management. So initially, we should know what is the sludge, right? So a sludge is a semi-solid slurry that can be produced from a range of industrial processes. So here, the sludge is obtained from different treatment steps. If we see, it can be produced from the primary treatment, or it can be from the secondary treatment, or it can also be from the tertiary treatment. Not only in the wastewater treatment, these sludge are also produced from different processes like the water treatment, wastewater treatment, and the on-site sanitation system. So here, the water treatment is it includes the waters present in the industries or domestic side. So whenever you are treating the water, the settled suspension here is termed as the sludge. And in the case of wastewater treatment from the STPs, okay, or the industries ETPs, the wastewater treatment produces a type of sludge called sewage sludge, okay. And the on-site sanitation system, these are the septic tanks or the pit latrines. So these systems are there in every household, right? So this on-site sanitation system produces a type of sludge called fecal sludge, okay. So now the different types of sludge includes the primary sludge, secondary sludge, mixed sludge, and tertiary sludge. So the primary sludge is produced by chemical precipitation or by the physical mechanism like sedimentation or any other primary process. During the primary process, the type of sludge produced is called the primary sludge. In the case of secondary sludge, these are the sludge produced from the secondary treatment process, where in the activated sludge process, so the activated biomass settled under after the biological treatment is called as the secondary sludge. We have a secondary clarifying tank, right? So after the activated sludge process, this tank will separate the clear water from the sludge deposited at the bottom, right? So this is where the sludge is produced, secondary sludge is produced. So next treatment step is the tertiary treatment. So this is the tertiary sludge is produced also from the tertiary treatment. Like after the disinfection, oxidation process, breaking down of the organic matter, some amount of sludge will be produced. In the case of mixed sludge, it is nothing but the mixture of the primary and secondary sludge. Okay, it is called as the mixed sludge. So what these sludge are all composed of? If you see the sludge composition, it is mainly of a solid and it will also have some amount of water in it. Okay, so these solids present in the sludge are further classified into two types. So one, the generally it is called as the total solid TS. So this total solid is divided into suspended solid and dissolved solid. This we have already discussed, right? So for example, if you are taking the wastewater and you are filtering it, then whatever the substances passing through the filter and getting settled down here are called as the dissolved solid. Okay, these are the dissolved solid, and whatever the substances settle down here in the filter paper itself. Okay, that is termed as the suspended solid. The suspended and the dissolved solids are further classified into fixed solid or a volatile solid. Like when these water or the filter paper are burned down in a muffled furnace, if the weight reduction happens upon the heating of these water or filter paper, so whatever the substances leaving the filter paper or the water content are called as the volatile solids. Okay, those are volatile in nature, and whatever is remaining after heating in the muffled furnace are called as the fixed type of solid because they are fixed. They are there even after heating also. Okay, so these are the some important terms you have to keep in mind. So here, in the case of problem solving, different formulas are there. One is the specific gravity of the sludge solid. If you are asked to calculate the specific gravity of sludge solid, you can use this formula, which is equal to 1 divided by Fs by Ts divided by 2.5, which is not the specific gravity, nothing but the specific gravity of solids in general, plus Vs by Ts divided by 1. Okay. Now here the Fs is the fixed solid and Ts is the total solid and Vs is the volatile solid. Okay. Next formula is the specific gravity of the sludge solid can also be obtained by using this formula, which is 1 divided by solid fraction of the sludge. Okay, solid fraction is the dry mass of the solid. Okay, divided by the sludge density. Sometimes it is unknown. Usually it is around 2.5. Sometimes it is unknown. We have to find it. And water fraction in sludge. How much percentage of moisture is there in our sludge? Okay, that is the water fraction. One is the water density is kept here as 1. Okay, which is constant. So with this introduction, we'll move on to the next topic, which is the need for sludge management. So why these sludge management are to be done? Because if you see, we are treating the wastewater. After taking out the clear water, the sludge are produced. Sometimes many toxic components like heavy metals, all the chromium, lead, copper, all these will be present in the sludge. And some kind of pathogens will also be there in the sludge. And some of the organic contaminants will also be in the sludge. So before the management of the sludge, these sludge cannot be disposed of. It is not very safer for the environment. We are treating the water and we cannot pollute the soil before without treating the sludge. Okay. So since they are containing these toxic components, it is very important to treat the sludge before disposing it. So how these sludge management are done means it can be an industrial method. Okay. So in the industrial method, what is commonly used is deposition. Deposition happens and incineration is nothing but burning of the sludge. Okay. To eliminate these kind of toxic components. Next is the thermal method. Thermal method is again heating. And non-industrial methods include the mechanical biological treatment, okay, physical mixing along with using the microorganism, or reclamation. We can do some reclamation of these sludge products and the environmental utilization. These are the, some of the non-industrial methods. In the case of industrial method, absolutely they are having higher amount of toxic component. To eliminate it, we are mainly incinerating it or using the thermal methods like heating to eliminate these toxic components. And this figure is talking about the method to be adapted based upon the type of the sludge. So if it is a primary sludge, then it will be having a lot of solid particles in it, and we can remove it by using gravity thickening. Okay, to reduce the amount of water, we can use gravity thickening. Next is the secondary sludge. Secondary sludge mainly uses the flotation process to remove these particles from it. Okay, after this only these sludge are passed on for further processing. So you will understand better in the next lecture. This is about the lecture 41, which tells about why sludge management is important, what is sludge, and what are the different type of sludge, how it is managed. And all. Okay. So now coming to the lecture 42, So it explains about the dewatering, drying, disposal, and composting. So in the lecture 42, first this is the sludge production to sludge disposal steps involved. So if you clearly see, once the sludge is produced, before disposing the sludge, lot of steps are undergone to treat the sludge. Okay. So the first step is the sludge concentration. Concentration can be done by gravity thickening in the case of primary sludge and flotation in the case of secondary sludge. Next thing is the digestion. So digestion is nothing but producing the methane or carbon dioxide gases by digesting the organic content present in the um, sludge matter. So it involves the anaerobic digestion, aerobic digestion, sludge lagoons. Next is the conditioning of the sludge. So in the case of conditioning, we can do some conditioning which will be very helpful for us before going for the dewatering or digestion and all. Okay. So now in the case of conditioning, we can use some chemicals or we can use the heat method to treat the sludge. Next is the dewatering. So dewatering is one of the essential steps so that the sludge can be concentrated very much. So it can be done by using centrifuging or filtration like pressure filtration, vacuum filtration, or using the drying beds or heat drying. These are some of the methods involved in the dewatering. Next step is the oxidation. So oxidation can be either by the incineration method or by using the wet air oxidation method. These are the different steps involved before involving the disposal of the sludge. Okay, in the sludge treatment, these are the different steps involved. So now coming to the dewatering. So as the name indicates, we are going to remove the water from the sludge matter. So removal of water can be done either through the filtration, okay, or by using the heating method. So in the filtration, the water is allowed to pass through the filter. In the heating, the water will get transformed into steam. So only the solid particles will be left out. So some of the equipment used for dewatering includes rotary vacuum drum filter. And this is a drum uh, which will be in contact with the slurry. And this drum is very helpful in separation of the water from the sludge. Next is the horizontal belt filter. So it is going to have a filter, belt filter. So the sludge will be passed from one end to the other end. So here the waste sludge will be removed as cake. So in the case of filter press, we have different frames, so through each frame, the sludge matter will pass through, and the cakes will be produced in the filter, and the clear water will be separated. Centrifuge is a method in which we use the gravity-based settling. So upon spinning in the centrifuge machine, so it will separate the solid particles from the liquid portion. Okay. Next is the drying equipment. So drying method can be a direct method or indirect method. So in the direct method, here the sludge will be directly heated. Okay. So what happens here is we can use the fluidized dryer so that our sludge will be in direct heat contact. In the indirect method, heat is not directly going to the sludge. We can use the disc type heaters to heat the sludge. So ultimate aim of using any filters or the drying beds is to remove the water from the sludge. Okay. Next step is the oxidation. So why oxidation is essential in the sludge treatment means some amount of organic content will be left out even after the secondary treatment. So to reduce the organic content before disposal, we are using this oxidation method. It can be a wet air oxidation method or it can be an incineration method. Major control variables involved in the oxidation methods are the temperature, pressure, amount of air supplied, and the solid concentration. Okay, these are the major control variables in the oxidation method. And coming to the disposal, after these many steps of treatment, ultimately we are going to dispose this sludge. Okay, how we are going to dispose this sludge into environment? It can be a open dumping, it can be a landfill, or it can be to the surface soil. Sometimes these can be batched into the seawater also. This is how the treated sludge is disposed of. Okay, and composting. This is the another method which can be adapted after the disposal. Like these kind of disposal, like open dumping, landfilling. So we have seen about the steps involved in the sludge treatment. First one is the concentration of the sludge. Next is the digestion of the sludge. Next is conditioning, dewatering, oxidation before disposal. We can dispose the sludge through open dumping, landfilling to the surface soil or into the sea. Sometimes these sludge can be efficiently used by the method called composting. So in the composting process, what happens is the transformation of biodegradable waste into biologically stable matter using the microorganism. So the composting can use bacteria or it can use the earthworms, which is another subtype of composting called vermicomposting. So it can use the microorganisms or other organisms. So the biodegradable waste matter present in the sludge can be converted into a stable matter. So over the course of time, the amount of nutrient in this waste matter will become constant and it can be used as a organic fertilizer for the crop production. Okay, this is one of the another method of good method of disposing the sludge material. So we have discussed this one. Like we have different kind of dewatering equipment. We can see this figure. This is the rotary vacuum evaporation, rotary vacuum drum filter, and so what is happening in this rotary vacuum filter means, so this is the slurry feed happening here. So the slurry level is maintained constant here. Over this there is a structure called drum. So this drum is called as the filter drum because it has the filtration setup inside it. Okay, when we are passing the slurry and this filter drum is constantly rotating here in this direction. So all the slurry liquid will be passing through the filtration setup and the clear water will be separated and all the uh, retentate matter, like whatever the substances which is not passing through the filter matrix will be settled upon this drum and these are eliminated in the form of filter cake here. Okay, so the filtration happens and the cake formation will also happen and washing is happening here and because this is an open surface, partial drying will also happen. So all these are happening simultaneously in this rotary vacuum filter drum. Okay, so this is one of the methods used in dewatering, and the next one is the horizontal belt filter. So this is the horizontal belt filter. This is the working mechanism. It has two rollers on either sides. So from one side we feed the slurry into it. So the slurry is passing through the belt, and finally after the filtration and washing, what happens is the cake formation happens. So cake is nothing but the retentate which is not allowed to pass through the filter. So these cake will be discharged at the other end. This is what happening in this horizontal belt filter. Okay, clear waters are separated and the solids are getting removed in the other end. And this is the next type of filter which is called as the filter press. So it has filters and frames. Okay, it is also called as frame and filter mechanism. So here, this is the frame. Okay. So all these blocks are called as the frames. So each and every frame is having a filter cloth in it. Okay. So when the wastewater, our sludge is allowed to pass through this frame, what happens here is the filtered clear liquid will be collected and it is passing through the tubes. So like this, the filtered liquid will be collected and the clear filtrate is exiting from the another end. And whatever the solid matter which is not allowed to pass through this filter cloth will be settling in between the frame itself. So whenever we remove these frames after the clear water collection, we can see the cake formation here in between the frames itself. This is the another type of dewatering method. So most commonly used one is the rotary vacuum drum filter because of its advantage of having the filtration, washing and partial drying, everything will be happening simultaneously. Okay, that is the major advantage of it. So now we have seen about dewatering, drying, oxidation and disposal. Next topic is in the lecture 43, we will discuss about the anaerobic digestion. So anaerobic digestion, we have seen this in detail already. But where this anaerobic digestion is coming in sludge treatment is here. After concentration, we can use the digestion of the sludge to produce many useful products. That is where the anaerobic digestion is coming in the sludge management. So anaerobic digestion is nothing but utilization of the anaerobic microorganisms. Anaerobic is a condition where no oxygen is required for the treatment of organic matter, right? So in the absence of oxygen, the organic matter is converted into many useful products like biogas, hydrogen, biofertilizer, and compost. The major steps involved are the hydrolysis, acidogenesis, acetogenesis, and methanogenesis. These are the four steps involved in the anaerobic digestion. We will see this in detail. If you see this figure, the first step is the hydrolysis. So what is happening in the hydrolysis means initially in our sludge, complex organic matter will be there. Complex, what is the word complex indicating here is it will be having the longer chain, longer carbon chain containing compounds, or it can be having these CH of a complex structure. So, since the microbial action is taking place for the production of these value added compounds, the microorganisms cannot take these complex organic matter as a substrate, okay, for the conversion into useful product. So, simpler molecules are required for the uptake by the microorganism. So, in the hydrolysis process, these complex matters like carbohydrate, proteins, fats are converted into the soluble organic molecules, which are easily assimilated by the microorganism. Like the carbohydrates can be broken down into simple sugars, and the proteins are broken down into amino acids, and the fats are broken down into the fatty acids. Now, these organic molecules are simpler in structure and are easily soluble. This breakdown of the complex matter into soluble substances is called as the hydrolysis. That is what happening in the first step. Next is the acidogenesis. So in the acidogenesis, as the name indicates, lysis is breaking down. Genesis means formation. So here in the acidogenesis, acid is going to be formed. So the small organic molecules are converted to volatile fatty acids. So fatty acids are produced in the acidogenesis step. Next is the acetogenesis. So again, genesis means formation. So acetogenesis. So here the acetic acid is formed. Acids are formed. Okay. Sorry. From the acid, acetic acids are formed. So the conversion of the volatile fatty acids to acetic acid and the CO2 is happening here in the third step, acetogenesis. Finally, the last step is the methanogenesis. Again, genesis means formation. Methanogenesis means methane formation. So from the acetic acid and carbon dioxide, what is formed is the methane and the CO2. Since this is the anaerobic digestion process, the end product will be methane. Okay, it is the biogas which is very helpful. It can be used as a cooking gas also, right? Now we have seen the four steps: hydrolysis, acetogenesis, methanogenesis. What are the factors affecting the digestion? So how this digestion process can be affected means by the solid content, amount of solid content in it. So whenever we are talking about the solid content, the other possible content in our sludge is the water. So when there is a lot of water present in our sludge, anaerobic digestion is very difficult to happen because when there is a water, it will be having a mixture of aerobic and anaerobic digestion. In the presence of water, O2 will also be there, right? So the efficiency will not be very good. Next is the ratio of carbon to nitrogen. Amount of carbon to nitrogen ratio is very important for the conversion, like for the sustainability of the microorganism during the anaerobic digestion. Next is the temperature, pH, and the retention time. How long this sludge amount of how much amount of sludge is there, how much is the solid matter content, and how long it is going to be retained in the particular digester. Okay. Next is the type of digester we are going to use. Okay. And then the microbe type. What type of anaerobic microorganism we are using for the conversion. All these are the important factors which are going to affect the digestion process. Now coming to the kinetics part, among the all four steps, hydrolysis, acetogenesis, and methanogenesis, it is said that methanogenesis is the rate limiting step. So the kinetics is mainly depending upon the methanogenesis step. Okay. Now coming to anaerobic digestion. So it is nothing but a reactor where anaerobic digestion is happening. The optimum conditions for a better anaerobic digestion are the temperature should be 30 to 38 degrees Celsius and the pH should be around 7 to 7.2. And one of the important thing is the dry solid content should not exceed 3 to 5 percentage, okay, of total weight in the digester. And then the maximum of 2000 mg per liter of BOD is allowed for the anaerobic digestion process. So this is the figure of an anaerobic digester. So in this one, we are allowing the sludge to pass through, and a mixing zone is here. So why mixing is important during the digestion means, so whatever the sludge present at the bottom should not be left unreacted. To ensure the homogeneity, the mixing is very much important. And then there is a separation of fluid from sludge. So the sludge will be produced at the bottom and the fluid will be present at the top. And whatever the gas produced after the anaerobic digestion process will be present in the top of the digester. So all the effluent gas and effluent substrate will be collected from the top of the anaerobic digester. Okay. So this anaerobic digester is further classified into low rate digester and high rate digester. So in the low rate digester, what is the condition here is intermittent mixing. So mixing happens intermittently, not continuously, and intermittent sludge feeding and sludge withdrawal. We can feed the sludge and we can take out the sludge intermittently. Okay, this is the conventional type of digester. Next is the high rate digester. So high rate digester is continuous mixing. So this continuous mixing will ensure the homogeneity of the sludge and the continuous or intermittent sludge feeding and sludge withdrawal will happen here. This is the high rate digester type. So this is the type of anaerobic digestion, and these are the steps involved during the anaerobic digestion process. So now coming to the lecture 44, we have seen about the sludge management in the previous three lecture. So this final lecture is about the industrial pollution control. So whenever there is an industry, there could be all possible pollutant, right? So there will be a gaseous pollutant, there will be a liquid pollutant, there will also be a solid pollutant. So as keeping this in the mind, so if you see the gaseous pollutant or the emission type of pollutant, so the emission control should be there, and then the effluent produced from the industry should also be controlled. Next, the solid waste produced from the industries should also be managed. So all the three type of pollutants should be controlled and managed from the industries. So what are the good methods to be followed in the industries to control the pollution means good housekeeping. So housekeeping is very much important and a regular inspection on the emission. So some persons are especially allocated for the quality assurance, right? All the emission standards or procedures are followed or not are checked by the personnel and proper documentation. So whatever the method followed in the industry, there should be a SOP, standard operating procedure, and all the procedures should be given to the personal working day, and everyday work should also be documented. And then the proper painting and color coding, so which is the dangerous and which is non-dangerous place, what is the hazardous chemicals used during the operation. So everything should be coded. And then segregation of the waste. So what are the level of treatment of the waste produced? All the waste should, organic and inorganic waste should be separated from the industries. Next is the consumption and production as per the government approval. So emission standards should not be overboarded. Like that, all the pollution levels should be within the controlled level. Okay. Next is the updated flow sheet. So these are the very important steps in the industrial pollution control. Now in this lecture, the example given is the sugar industry. So in the sugar industry, different possible way of pollution control are mentioned here. One is the wastewater source controlling. So in the case of wastewater, how these wastewater are produced means it can be a overflow from the cooling tower, or it can be the process wastewater. That is the water used during the process of sugar cane. And then the evaporated tube cleaning wastewater, the water coming from the evaporated tube. So these are the different sources of wastewater. And then treat the wastewater streams separately. So each and every stream should be treated separately to avoid the bulk mixing of the contaminants they are taking. And then the air and noise pollution abatement. This is also very important. Air quality should be maintained and noise pollution should also be avoided. So this is the general working of the sugar industry. These are all the different processes involved during the sugar production. So firstly, the sugar cane is collected from different region, and this is shredded in the shredder. So the particle size reduction happened here. And in the milling train, so milling is again reduction of the particle and separation of the solid liquid. Okay, so here we are spraying the water and we are extracting the juice from the cane. Okay, and whatever the left out matter after extracting the juice is called as the bagasse. So this bagasse is passed to the boiler station where it can be used for co-firing material, okay, for the power production. So once the juice are separated, this is the mixed juice tank. So all the juices are collected to this tank and then they are heated at higher temperature in the heaters. Then the lining happens. So lining of the juice is happening. So after collecting the juice, it is heated and the lining is happening. Now it is going to this tank. So in this tank, what is happening means the clear juice and muddy juice are separated. So the clear juice are passed down for the further treatment, And the muddy juice is again going to the rotary vacuum filter. Just now we have seen what is this rotary vacuum filter. So it is a drum where the slurry will be here and it will be in contact with the slurry. It is keep on rotating like this. So washing will happen simultaneously and the partial drying will also happen and all the mud will be separated from the juicy material. Okay, this mill mud is going to be careful. And then the muddy juice is separated. So coming to the clear juice section, so it is going through the evaporator. Okay, this is very important step. So in the evaporator, the high temperature, what is happening? So these clear juice are converted to sugary liquid. Okay, so this sugary liquid is again going into this vacuum fans. Okay, why means it is going to be mixed with the mother liquid and upon the process it is going to produce the muscat. Okay, so this muscat is the product which is going to be further used for the production of the sugar crystals. Okay, so the pure crystals are separated from the molasses and again after drying these sugar, these raw sugar are stored in bulk, okay, in the storage. So if you see this process, we are using the water here in the milling train, and again we are using the water for washing of the muddy juice. Okay, and we are using the water uh, here in the form of steam, and again we are using the water here in the form of steam. So here also the water spray is happening. So we are using the water at the different processes. Okay, so all these water should be collected and treated, and mainly they are telling the water used in the evaporator will be having higher amount of COD. So they are expecting the treatment of the wastewater streams separately to ensure the pollution control. Okay. For maximum efficiency, they are suggesting the separate treatment. So this is one example about the sugar industry in industrial pollution control. Further industries will be discussed in the upcoming lectures, okay, in the next week. So now with this introduction about the week 9 lecture, we will move on to the sample questions of week 9.
இப்போ ஆப்ரேட் போயிடுவேன்
Do
நிறைய
you have,
ஒன்று யாருமே ஜாயின் பண்ணல நான் மட்டும் தான் இருக்கேன்
please mute yourself.
நான் போயிட்டு தான் மூடிட்டு போயிடுவேன்
Please mute yourself. So now coming to the sample questions of assignment 9. The first question is specific gravity of sludge solid can be estimated by. So this is the formula to estimate the specific gravity of the sludge solid. We have discussed this earlier itself. Like I said, there is a different type of solid. Like the total solids are further classified into suspended solids and dissolved solids, and both the suspended and dissolved solids are further classified into fixed solid and volatile solids, right? So by using the fraction of fixed solid to total solid and the volatile solid to total solid, we can obtain the specific gravity of the sludge produced, right? So the correct formula is 1 divided by Fs by Ts divided by 2.5. This is the actually assumed amount of specific gravity of the solid content. Okay, and then the Vs divided by Ts, one is the assumed specific gravity of the water in. So this is the right one. Next question is the favorable condition for the treatment of sludge using the wet air oxidation process. So in the wet air oxidation process, what is the temperature and pressure used? Is it a 400 degrees Celsius and 500 to 800 kilopascal, or 150 degrees Celsius and 600 to 1000 kilopascal, 350 degrees Celsius and 800 to 1200 kilopascal. 260 degrees Celsius and 8000 to 12,000 kilopascal. So, what is the favorable condition used in the treatment of sludge using the wet air oxidation process? So, the right answer is 260 degrees Celsius. It is a temperature condition, and the pressure should be 8000 to 12,000 kilopascal. Next question is factors affecting the composting process. So we know that composting is a method which will be degrading the leftover biological content into the stable form of organic matter. Right. So the stable form is formed by using the microbial action. So we use the microorganisms in the composting process. So now the factors affecting the composting processes are oxygen and aeration, particle size and carbon to nitrogen ratio, temperature and time, all of the above. The right answer is all of the above because all the parameters are very important, like amount of oxygen and aeration required because it determines the growth of the microbe and uptake of the substrate. Okay, and the particle size is also very much important, above which the carbon to nitrogen ratio is also important to ensure the microbial breakdown, and then the temperature of the process and the time taken for the conversion. So all of the parameters are very important during the composting. Next question is, which of the following statement is not true about anaerobic digestion? A series of biological process, microorganisms break down and break down the biodegradable material. It requires oxygen, none of the above. It is very simple. They are asking you about the anaerobic digestion process, so which absolutely does not require the oxygen. So the false answer is the requires oxygen. Next question is, which of the following product is not formed by the anaerobic digestion of biomass and MSW? MSW is the municipal solid waste. So, which of the following is not the product formed after the anaerobic digestion they are asking? So, in anaerobic digestion, the end product will be the methane carbon dioxide, and the left out sludge can be used as the biofertilizer, right? And maybe some amount of water content present in it can be used as a reusable water. But only the thing which cannot be formed during the anaerobic digestion is the bio oil. No oil is formed during the anaerobic digestion of biomass or the municipal solid waste. So the product which is not formed by the anaerobic digestion is bio oil. Next question is, which of the following factors affects the biogas yield in anaerobic digestion? So we know that CH4 methane and the carbon dioxide are the end product of anaerobic digestion. So to ensure this conversion efficiency, what are the factors important? Temperature, retention time, microbe type, all of the above. Right answer is all of the above. So the temperature is very important. Retention time. So how much time the sludge is residing in the anaerobic digester is also important. So next is the type of microbe we are using during the anaerobic digestion. So all the three are very important factors which are going to affect the biogas yield. Next question is, which one is a biological method used for removal of organic compound from wastewater? Adsorption, photochemical oxidation, nanofiltration, phytoremediation. So all these methods are useful in the removal of organic compound from wastewater. Uh, but they are asking you about the biological method. So biological method should be using the microorganism, right? So the right answer is phytoremediation. Okay. Next is, which of the method is the physico-chemical technology? Which one is a physico-chemical technology used for the removal of organic compound from wastewater. Fungal treatment, aerobic treatment, anaerobic treatment, absorption. So here the question is which is a physicochemical technology. All the fungi, aerobic organisms, anaerobic organisms are all the biological treatment based method, right? Biological method. So the physicochemical technology used here is only the absorption method, where the absorbents are used to capture the contaminants, which is nothing but absorbate. Okay. So absorption is the right answer. It is the physicochemical technology used for the removal of organic compound from wastewater. Next question is solid waste is generated in residential area and in office may be considered as. So the solid waste is generated in the residential area and in office zone are considered as hazardous waste or municipal solid waste, medical waste or none of the above. Mainly, the waste generated in the industries are classified as the hazardous waste, and the hospital zone waste are classified as the medical waste. And the waste generated in the residential areas are only termed as MSW, which is nothing but municipal solid waste. Next is a problem. The question is a sedimentation tank is treating 5 mld of sewage containing 290 ppm of suspended solids. The tank removes 60% of the suspended solid. Calculate the weight of the sludge produced per day, assuming the moisture content of the sludge as 90%. So the options are 7,720, 8,700, 9,150, 9,920 kg per day. So the right answer is 8,700 kg per day. It will solve this problem here. Okay. So in the given question, it is mentioned that there is a sedimentation tank. Okay. So this sedimentation tank is treating the capacity of 5 mld of sewage wastewater, that is 5 million liters per day. And the concentration in it is given as 290 ppm. 1 ppm is equal to mg per liter. Okay. So it can be written as 290 mg per liter. So this is the flow rate of the wastewater, which is 5 mld. So 5 mld is equal to 5 into million is 10 power 6, right? So 5 into 10 power 6 liter per day. And ppm is written as 290 mg per liter. Okay. So a sedimentation tank is treating 5 mld of sewage containing 290 ppm of suspended solid. The tank removes 60% of the suspended solid. So efficiency of removal is only 60%. Okay. Calculate the weight of the sludge produced. So they are asking you about the weight of the sludge produced per day. So your answer should be in kg of sludge produced per day, assuming the moisture content of the sludge as 90%. So a sludge is a semi-solid component. So here the water content is given as 90%. Okay. So coming to the solution, the flow rate Q is 5 mld, so which is written as 5 into 10 power 6 liter per day, and the concentration of the solid is given as 290 ppm, which is 290 mg per liter, and concentration of the solid produced as sludge. How much is produced as sludge means 60%. So multiply the efficiency into the concentration of the sludge. Uh, Concentration of the solid, so which is nothing but 60 by 100 into 290, which is 174 mg per liter. This is the concentration of solid produced as sludge. Okay. Now the total dry mass of the solid are calculated. To calculate the total dry mass, so total dry mass means out of the 5 million liter per day, okay, how much amount of sludge are formed per day? So we are treating 5 million liter of sewage wastewater in a day, and for per liter of wastewater, 174 mg. out of 290 mg are produced as a sludge matter. So the total dry mass solid can be given by multiplying the flow rate into the sedimentation tank into the concentration of the solid in the sludge. Now here the flow rate is 5 mLT and the concentration of solid in the sludge is 174 mg per liter. So it is in liters per day and this is in mg per liter. Right. Now we are converting this mg to kg. So again the answer will be represented in kg per day, which is nothing but m is given as 870 kg per day. So 5 mLT is nothing but 5 into 10 power 6 liters per day into 174 mg per day. So mg is nothing but 10 power minus 3 grams per day, mg per liter. So 10 power minus 6 into 10 power minus 3 is again 10 power 3. We can write the 1000 grams into kg. Liter will get cancelled. So 870 kg per day. This is the total dry mass of solid in the sludge. This is written in kg per day. Okay. Again, we are going to find the mass of the sludge. That is what the question. Weight of the sludge produced per day, assuming the moisture content. So the fraction of moisture should be eliminated from this one, and we have to find the amount of sludge produced in terms of kg per day. For this, the equation is 100 divided by 100 minus b. It is the amount of moisture percentage, which is given as 90 into the mass of the dry solid, which is nothing but 870 kg per day. So the final answer is mass of the sludge produced per day is 8,700 kg per day. Okay. Now this is also a similar type of question. You will understand it better in this problem itself. So the question is a sedimentation tank is treating 4.5 mLT. So here the flow rate can be written as 4.5 into 10 power 6 liter per day. Okay, that is the flow rate Q. This much amount of wastewater is getting treated per day. And now it is containing 275 ppm of suspended solid. So 275 ppm can be again written as 275 mg per liter. And the tank removes 55% of the suspended solid. So the efficiency of removal is given, right? So out of the concentration of 275 mg per liter, only the 55 percentage is converted into the sludge. Okay, so the concentration of solid produced as sludge is efficiency into concentration of solid, which is 55 divided by 100 into 275, nothing but 151.25 mg per liter. So this is the concentration of solid produced as the sludge. And now the question is, find the weight of the sludge produced per day, assuming the moisture content as 96%. If the specific gravity of the sludge is 1.02, calculate the sludge quantity in bulk. So we are going to calculate the volume of the sludge and we are going to calculate the weight of the sludge per day. So two questions are there. First one is to calculate the weight per day. For this, we need to find the amount of sludge produced in a day, and then we have to use the moisture content in the formula to find the final mass of the sludge produced per day. So now to find the total dry mass, as we did earlier, we have to multiply the flow rate with the concentration of solid in the sludge. So our flow rate is 4.5 mLD, and again the concentration is given in mg per liter. We can convert it into kg per day. So the right answer is m is equal to 4.5 into 151.25 is nothing but 680.625. Okay, this is the total dry mass of the solid in the sludge. So now the m is found. We are going to find the mass of the sludge by using the moisture content percentage. So use the same formula, which is 100 divided by 100 minus P into M. So substitute the percentage, which is 96, and multiply it with M. So the dry mass is 680.625. So the amount of sludge produced per day is 17,015.625 kg per day. Okay. Now to find the sludge quantity in bulk, we know that density is equal to mass by volume, right? So density is equal to mass by volume. Now we have found the mass of the sludge, okay? And we also know the density. So the specific gravity of the sludge is given here. With this, we have to find the density. So density is equal to specific gravity of sludge into density of water. This is how the density of sludge is found. So 1.02 into 1000. Okay, this is constant always. This 1000 kg per meter cube. So here 1020 kg per meter cube is the density of the sludge. Now we can easily find the sludge quantity, which is volume is equal to this is the mass of the sludge produced per day, right? So this is in kg per uh, day, and this is the uh, density of your sludge, which is identified from here. Okay, substitute this 1020 here and divide both of these. You will obtain the volume produced. Okay, so the volume of the sludge quantity in bulk is 16.68 meter cube. Okay, this is how the sludge quantity is obtained. First part is to find the weight of the sludge. Initially, to find the weight of the sludge, you need to find the dry mass in it. To find the dry mass, you have to multiply the flow rate, the concentration of solid in sludge. So this concentration of solid in sludge is obtained by multiplying the total concentration of solid into efficiency of the removal. Okay. And then finally, to find the sludge quantity, nothing but the volume, we can use this relation density is equal to mass by volume. To find the density of the sludge, multiply the specific gravity of the sludge with the density of water. Okay. Now coming to the second problem, the question is to find the specific gravity of sludge if it contains 70% of volatile solid with a specific gravity 1.7 and the remaining non-volatiles with specific gravity 2.7. Moisture content is given as 98%. This is very simple problem. In the given question, write out the data. First, the solids in the sludge mantle is classified as the volatile solid and non-volatile solid. Right. The percentage of volatile solid is 70. That is written here. And the percentage of non-volatile solid is the remaining. So 100 minus 70 is 30. Okay. So 100 minus 70 is 30 percentage, and the specific gravity of volatile solid is given as 1.7, and the specific gravity of non-volatile solid is given as 2.7. We have to use this relation to arrive at the specific gravity of the solid first. Okay, the question is to find the specific gravity of sludge. To find the specific gravity of sludge, we have to use this relation 1 divided by specific gravity of sludge is equal to fraction of the solid divided by the specific gravity of the solid plus fraction of the water. This is the weight fraction, okay? Fraction of the water and the specific gravity of water. You should know that specific gravity of water is constant, which is nothing but 1. So the specific gravity of solid is obtained by using this relation, which is the individual fraction, like percentage volatile divided by the respective specific gravity plus the percentage non-volatile divided by the respective specific gravity. Okay. Now substitute the given data: 70 divided by 1.7 plus 30 divided by 2.7. You have to find the reciprocal of this one, and you have to bring this 100 on this side, and finally you will obtain the specific gravity of solid as 1.91. Okay, if you solve this one, you will obtain the value of 1.91. Now just substitute this 1.91 to here. And in the question, it is clearly given the moisture content is only 98%. So the remaining 2% is the weight fraction of your solid, right? So substitute the 2 here. This is the percentage solid. Here substitute the percentage water, and the specific gravity of water is 1. Now you have found the specific gravity of solid 1.912. Substitute it here. Okay. If you solve this one, you will obtain the specific gravity of sludge as 1.009. With the help of these two formulas, you can easily find the specific gravity of sludge. First, to find the specific gravity of sludge, we have to know the specific gravity of solid. To find the specific gravity of solid, we have to find the individual percentage of the volatile, non-volatile, and divide it with their respective specific gravity and add them. Okay, then you will get the solid specific gravity. Okay, this is a very simple problem. If you understand this, next problem will be very much easy. So now coming to the next question, I hope no doubts are there. Do you have any doubts so far? Because next problem is based on this one. Any doubt? Okay. So the next question is the water content of solid slurry is reduced from 98 to 95 percentage. What is the percent reduction in volume, assuming that the solid contains 70 percentage of organic matter of specific gravity 1 and 30 percentage of mineral matter of specific gravity 2? What is the specific gravity of 98 and 95 percentage slurry? Okay. So the question is very simple. So it has two questions in it. One is to find the specific gravity of the slurry at 98 percentage water content. Okay. Next question is to find the 98 percentage slurry. Okay, not water content. Next question is specific gravity of slurry for 95 percentage. To find either of these one, we have to find the specific gravity of solid, right? So the specific gravity of solids can be obtained from assuming that solid content is 100 percentage. Out of this 100 percentage, what is the weight fraction of the organic matter, and dividing it with the respective specific gravity of the organic matter, okay, plus weight fraction of the mineral matter, dividing it with the respective weight fraction of the specific gravity of the mineral matter. Okay. Now, this is what we arranged and solved here. Okay. So the first question is W1 is 98 percentage. So 98 percentage is the amount of moisture only, and 2 percentage is the solid content. So the second part is having 95 percentage moisture content, 5 percentage solid. Okay. This solid content is increased due to the dewatering process. So some amount of water is removed. So the percentage of solid in it is increased. Okay. Now this is the general equation. We will come to this later. So in this problem, so S is given as the specific gravity, W is given as the weight. So rho W is mentioned as density of water. Okay. So we have to solve this step by step. The water content is 98 percentage and 2 percentage solid. In the 2 percentage solid, 70 percentage is the organic matter and 30 percentage is the mineral matter content. So all these are mentioned in the fraction, okay, weight fraction. So 70 by 100 is 0.7 W solid, and 30 percentage is the 0.3 of the W solid. Okay. Now just note down the specific gravity of S mineral and S organic. It is 2 and 1 respectively. Okay. Now you use this formula, which is W solid divided by S solid is equal to 0.3. This is the 30 percentage, okay, of W solid divided by 2. This is for mineral content. Okay. And for organic content, 0.7 divided by its respective specific density, which is 1. Okay. So you just substitute them here. It is very simple if we solve it here. Okay. So finally, we will obtain the specific gravity of the solid as 0.85. Okay, all these are in the fraction. Instead of 100, we can keep it as 1 here, and we can substitute zero point 0.7 and zero point 0.3 here, or it can use 170 and 30 here. We will obtain the same answer, which is 1.18. This is the specific density of the solid. Okay, so the specific density of solid will not change based upon the percentage of the slip. Okay, this is constant. Now, to find the specific density of the sledge, so we find the specific gravity of the sledge, that is the slurry of 98%. It is very simple. We already know the formula, right? The same formula we can use, which is 100 by specific gravity of sludge is equal to percentage of solid divided by specific gravity of solid plus percentage of water divided by specific gravity of water. The same formula we can use, which is nothing but use the same formula. 100 divided by specific gravity of sludge. Okay, so this is solid, we can keep it as slurry. So specific gravity of slurry is equal to weight fraction of the solid, and then the specific gravity of the solid plus weight fraction of the water divided by the specific gravity of water. This is 1, right? And this is just now we have found. This is 1.18. Only thing that is going to differ is the moisture content. So for 98 percentage, substitute here the solid content as 2 percentage and 98 percentage here. For 95 percentage, substitute the solid content 5 percentage here and 95 percentage here. Based upon this, the value will change. See here, this is how it is calculated for the case 1. So 1 by specific gravity of sludge is equal to 0.98 divided by 1 plus 0.02 divided by 1.18, which is nothing but 0.9969. So now 1 by S sludge is 0.9969. So S sledge is obtained by taking the reciprocal of this, nothing but 1.003. Okay, this is the specific gravity of the sledge. We have obtained it. Now, the specific gravity of sledge for 94%, substitute 0.95 and 0.05 here. We will obtain 1.007 as the specific gravity of sledge for 95% moisture content. Okay. So now, um, what we are going to do is to calculate the volume reduction. How much is the volume reduced? That is the actual question here. So initially 98% moisture was there and then 95% moisture was there. For both the cases, we need to find the volume and then we need to calculate the percentage of volume reduction. Already I have mentioned to like density is equal to mass by volume. Keep this relation constantly in mind to find the unknown. Now to find the volume, you have to divide the mass of the sludge with the density. Okay. So for 1 kg mass of solid, the volume of solid can be obtained by 1 divided by the solid content into density of the sludge. So now the solid content is nothing but 0.02 and the density is obtained as 1.003 for the first case. Now we will easily obtain the volume, which is 29.85 liters. Okay, this is for 98%. Similarly, we have to find the solid treatment waste. After the solid waste treatment, the water content is 95%. So for 1 kg mass of the solid, find the volume of the sludge again. So the volume of the sludge is 1 divided by 0.05 into 1.007, which is 19.86 liter. To find the percentage reduction, the relation is initial volume, final volume divided by the initial minus final divided by initial. This is simply written as 1 minus VF, final volume by initial volume. Just substitute the values here. 1 minus after treatment the volume is 19.86. Initially the volume is 49.85 into 100. This is the percentage volume reduction. So the percentage volume reduction is 60%. Okay. This is how you have to calculate the percentage volume reduction. Next question is using the following primary settling tank data, determine the daily sludge production. So here we are going to calculate the daily sludge production and the operating data are given here. So the flow rate is 0.1 meter cube per second. This is the flow rate. And then the influent suspended solid is, so the concentration is given here. So the concentration of solid is 240 mg per liter, which is nothing but 240 gram per meter cube. Since the flow rate is in meter cube, it is converted to meter cube. We know the relation, right? 1 meter cube is equal to 10 power 3 liters and 1 gram is equal to 10 power 3 mg. So both these 10 power 3 will get cancelled. We are obtaining the same 240 mg per liter as 240 gram per meter cube. And now the removal efficiency eta is given as 69%. Sludge concentration is 5%. In this solid content, the amount of volatile solid is given as 60% and the specific gravity of the particular volatile solid is 0.99 and the fixed solid percentage is 100 minus 60 is 40 percentage and the specific gravity of the fixed solid is 3.65. So all the data are given here. Now it is very simple. It is looking complicated here, but it is very easy. We are going to use the same relation. Okay, to find the amount of that is the specific gravity of solid. Okay, we know the relation. 100 is the assumed weight of the solid, right? So the weight of the solid is kept here as the ms, which is nothing but the mass of the solid. Okay, we generally assume it as 100. Instead, we are keeping it as ms in the formula here. So that divided by the specific gravity of the solid. Then we know that two type of solid present here is the volatile and fixed solid. Just take the mass of the volatile solid with the specific gravity of the volatile solid plus mass of the fixed solid, which is mf divided by the specific gravity of the fixed solid. Just cross multiply these one, we will obtain mp into sf plus mf into sv, which is the specific gravity of volatile solid, divided by sp into sf. So this is equal to ms by ss. To find the SS, that is the specific gravity of solid, take the reciprocal of it and you have to multiply it with ms, right? So that is what given here is SF into SV divided by MF into SV plus MV into SF into ms. So ms is the mass of the solid. Okay, to find the mass of the solid, we have to add both the mass of volatile and fixed solid, which is nothing but 0.6 and zero point 0.4 is equal to 0.6 plus 0.4 is equal to 1. Okay, that is the total amount of solid. Now, the mass of the MF is zero point 0.6, which is substituted here, and the mass of the volatile solid, which is zero point 0.4, is substituted here. Okay, in the formula. And then the specific gravity is also given 0.99 and 3.65. Just multiply them here and substitute correspondingly here. You will obtain the specific gravity of solid as 1.39. Now the first case is solid. Again, to find the specific gravity of the sludge, we are going to use the same formula, which is nothing but 1 by specific gravity of sludge is equal to, okay, fraction of the solid. So the fraction of the sludge solid is given as here. Okay, Ps divided by specific gravity of the solid Ss plus fraction of the water. Okay, basic sludge is going to contain only the solid and water. So fraction of water divided by the specific gravity of water. Here we know that specific gravity of water is 1. So this is eliminated. This is kept as 1. Now just cross multiply it. You will obtain PS plus PW into SS. Because SW is 1. So 1 into PS is PS plus PW into SS whole divided by 1 into SS is SS1. Okay. This is for 1 by specific gravity of sludge. To find it for S sledge, just take the reciprocal. So that is given here as SS divided by PS plus SS into PW. Substitute all the known values. Just now we have found the specific gravity of solid, which is 1.39, and the PS fraction of solid is, we know the sludge concentration is 5%. Okay, so the sludge concentration is 5%. The moisture percentage is 100 minus 5 is 95%. Okay, so this is the moisture fraction, PW. So 95 by 100 is 0.95, and you are multiplying it with the S's, which is 1.39, and then 5 by 100 is 0.05. This is the fraction of solid. So we have substituted all the values. If you solve this one, you will obtain the specific gravity of sludge as 1.09. Now, with this, the question is to determine the daily sludge production. So you are going to find the volume, how much volume of sludge is produced. Before that, we need to calculate the mass of the sludge produced in a day, okay, kg per day. So what we have to do is, we have to multiply it with the removal efficiency and the flow rate 0.1 and the amount of solid. So if you multiply the efficiency with the concentration of solid, we will obtain the total amount of solid produced as the sludge, right? So everything is done in a single step here. So efficiency into the concentration of solid will give you the total amount of solid produced as the sludge. Then we are multiplying it with the flow rate. So this is the same as we did earlier. So this will give you the dry mass amount of the sludge produced. So here the flow rate is in meter cube per second. To find it per day, you are multiplying it with 86,400. In a day, 86,400 seconds are there, which is nothing but in a day 24 hours are there, in a hour 60 minutes are there, and again in a minute 60 seconds are there. So you are just multiplying it with 86,400. Here it is in mg per liter. So we are converting it to gram. So here what happens is initially the mg per liter is when converting to meter cube, it cancel this one, and then the gram will be remaining. So to convert the gram to kg, we are multiplying it with 10 power minus 3. Okay, that is what happening here. Unit conversion is there. Now the mass of the sludge is obtained as 1.43 into 10 power 3 kg per day. Now to find the volume, we have to divide it with the density, right? And we should also multiply it with the weight fraction of the sludge. Only the 5% is the sludge, and then we have to multiply it with the specific gravity of the sludge, okay, the denominator. This is the thumb rule. That is what we have done in the previous case also. So now 1.43 into 10 power 3 is the mass of the sludge produced in a day, and the density is 1000 kg per meter cube, and then the specific gravity of the sludge is 1.09, just now we have calculated, and the fraction of the sludge is 0.05. Okay, so this is how we are calculating the volume of sludge as 28.1 meter cube per day, which is nothing but the daily sludge production. Okay, in terms of volume. So now coming to the last problem of today's session. The question is 200 meter cube of mixed sludge. So 200 meter cube is the volume capacity. Okay, 200 meter cube of the mixed sludge at 5% solid. So this is a concentration of solid in it. Is to be thickened to 10% solid. So thickening is the procedure happening here. So in the 200 meter cube of mixed sludge, 5% of solid is to be thickened to 10%, assuming the specific gravity is not appreciably different from that of the water. Okay, specific gravity is not different from water they have given, and that it does not change during the thickening. So it is not changing after the thickening process also. The condition is same. What is the approximate volume of the sludge after the thickening? So we are about to calculate the volume of the sludge after thickening. So this is the block diagram of the process. So here the process is thickening. Okay, thickening is nothing but concentration. So your solids content will increase and the water content will get decreased. Out of the 5% solid in the 200 meter cube capacity of mixed sludge, 10 percentage of the sludge is thickened here. Okay, and the supernatant. So the sludge will be there deposited at the bottom, that is collected, and the clear water zone here is called as the supernatant. So what is the concentration here in the supernatant means, that is C3. Volume of the supernatant is taken as V3, and the thickened sludge concentration is 10%. This is the concentration of solid in the thickened sludge. It is given in the question itself. Next, the volume of the thickened sludge is the exact one asked in the question. Okay. Now to solve this one, we have to take the mass balance. That is, whatever coming in is equal to whatever going out. So here the inlet is only the mixed sludge, but the outlet streams are two different streams. One is the thickened sludge and the next one is the supernatant. So balance the equation. So if it is leaving the system, we have to take it in minus. If it is entering the system, we have to take it in plus. So C1 V1 is minus C2 V2 because it is leaving the system. And then C3 V3 is also leaving the system. So minus C3 V3 is equal to 0. Now, there exists an assumption that the supernatant concentration, so the concentration of solid in the supernatant is very, very, very less. Like C3 is very, very, very less, insignificant amount than the C1 and C2. Okay, so we can take the C3 value as 0. Okay, so if you are taking C3 as 0, this term will get cancelled. So C1 V1 is equal to C2 V2. We know the concentration initially in the mixed sludge, which is 5%, and the initial volume is also known. Final concentration is also known. It is very easy to find the volume. Only assumption you have to take is C3 as 0. Okay, because of its very less negligible concentration. Now, substitute the concentration 5%, so 5 by 100 is 0.05. Volume capacity is 200 meter cube, so 200 divided by 10 percentage is 10 by 100, so 0.1. So the answer is 100 meter cube. This is the, so 100 meter cube, this is the volume of the thickened sludge after the thickening process. Okay, this is the right answer. So now this is a similar problem like the previous one. You can solve it by yourself. So there is a thickening tank. Okay. So I will read the question. 300 cubic meters of mixed sludge at 8% solid is to be thickened to 15%. Assuming the specific gravity is not appreciably different from that of water and it does not change during the thickening also. What is the approximate volume of the sludge after thickening? So there is a thickener tank. So this is the thickener. Similar to the previous one, we have to draw the block diagram. So this is the thickener. So the inlet to this system is 300 meter cube. So the volume V1 is 300. Okay. So inlet is 300 meter cube. And then the amount of solid content in the mixed sludges. So the initial concentration C1 is taken as 8%. Now two systems are leaving. Okay. This is the mixed sludge. Right. The mixed sludge is passed into the thickening tank. So mixed sludge is here. So two systems are leaving the thicken. One is the supernatant. So here in the supernatant, the concentration of the solid is taken as the C3 and the volume is taken as V3. And this exit stream is the thickened sludge, right? So for the case of thick and sludge, the concentration of the solid and the volume of the sludge is taken as C2 and V2, like the similar, like the previous process. So it is C2 and V2. Okay. So this is C2 and V2. Now with this one, we are going to do the mass balance. So C1 V1 minus, you can also write this is in and this is out. So C2 V2 plus C3 V2. As in previous case, C3 is very much less than the C1 and V1. So eliminate this term. So you will have C1 V1 is equal to C2 V2. Now we can easily solve this problem. C1 V1 is equal to C2 V2. So V2 is equal to C1 divided by C2 into V1. Initial concentration is 8%. So 8 by 100 is 0.008. Final concentration is, sorry, that is a mistake, right? So the final concentration is 15%. So 15% means 15 by 100 is 0.15. And the volume is, initial volume is 300 meter cube. So if you solve this one, you will obtain V2 is equal to 160 meter cube. This is the right option. Okay. So thank you. We have solved some problems based on the sludge management concept today. I hope it is clear. Do you have any questions? Any doubts so far? Any doubts so far? Okay. If no doubts, we can end the session. Thank you for joining today. We will see you in the next Saturday class from 3 p.m. to 5 p.m. And you can find the recorded videos in the YouTube channel, and the presentation will be uploaded in the Drive link. Thank you.